My name is Jerome Holman, and I work in the Windows Devices group at Microsoft. It's basically a team where we build cool stuff, tablets, phones, things like HoloLens that hopefully will excite and delight customers. Computers are not infinitely fast, but they are much faster than human beings at many tasks. In 2014, the fastest computer in the world was clocked in at an astounding 33 quadrillion calculations per second. Now, for some tasks like composing a song, we generally think human beings still do a better job. For highly repetitive tasks that can be automated, computers are much, much better. Programming languages usually have a few different ways to define and control behavior that should repeat. These are usually called loops. They go by different names in different languages like for loop, while loop, do while loop, for each loop, repeat loop, and so on and so forth. These types of loops have small differences, but all of them are just different ways to get the computer to execute some lines of code repeatedly. The generic term for looping is iteration. Iteration is just a fancy word that means repeat. It usually is in reference to the repetition of a process or a procedure. This is why iteration is a good generic term. Often in programming, we have an algorithm that just needs to repeat a specific number of times, or repeated while some condition holds true. We're going to show you how to use a looping structure called a for loop in JavaScript. You can find for loops in the control section of the toolbox. It looks like this when you drag it out. A for loop in JavaScript, like this one, is just a type of counter loop. It counts up from 0 to the number you type in. Why does this simple for loop look so complicated? JavaScript, unlike some languages, doesn't provide a simple repeat loop structure. The for loop is a very powerful and versatile looping structure for both advanced and simple tasks. We're just keeping it simple for now. Let's do a little experimentation. You can drag any commands you like inside the for loop block. These commands will be executed over and over for however many times you specify in the loop. When you run the loop, notice the app lab highlights each line as it executes. Now, why does the for loop block highlight after each iteration of the loop? That's because the for loop needs to check its counter every time to see if it should stop or run the commands inside the loop one more time. Well, that's not terribly exciting, but it's because we're not really using the computing power that looping gives us. Instead of looping this piece of code 4 times, let's loop it, 200 times and see what happens. Now that's more interesting. One thing to note about loops is that your code will still execute from top to bottom as before. You can put lines of code before the loop if you need to get something set up before the loop starts. Likewise, after the loop is done executing, it will pick up on the line right after the loop. For example, if you want to move the turtle before drawing this figure, I could use a move to command before the loop. And if I want to draw a red dot to see where the turtle ends up, I could add lines after the loop. You will use the same top-down design in many of your projects. These problem-solving techniques will help you identify where loops belong in your code. You still might want to write a function to do a small part of your program, and then write a loop to call that function. Take, for example, the problem of trying to draw this. You might recognize that this is just a bunch of squares, each one rotated slightly before being drawn. Previously, we would have had to make a function to draw a square. To get the 10 rotating squares, we would have had to call this function 10 times, turning a little each time after we called the function. This would have involved a lot of copying and pasting. This code works, it does, but it's very repetitive. Let's just see if we can simplify our code with a loop. We already have a working function that does a piece of the problem once. We can easily stick the function call into a loop to do it multiple times. Clarity and readability are important considerations when programming. As we can see, this code is now much more readable. It's obvious just from looking at the loop that the intent is to draw a square a bunch of times. Loops are a powerful programming construct that uses the computer's primary advantage over humans, that being their amazing speed. By repeating commands as many times as we wish, loops allow us to solve new problems at a scale that would be impossible without computers. There is still much to learn about the loop, but the concept is simple. Loops repeat commands as many times as we need. Now you know how to use a simple loop. You can use them in your programs and take advantage of your computer's power and speed.